Hi, Jackson.
Hello.
You got any new material tonight, or you want to continue working on that document we were looking at yesterday?
No, it's just review for the quiz tomorrow.
Okay.
But for my homework tonight, I've already done it, and I did most of it with the teacher. Can we still go over problems? Like here, I'm going to read you one. It's a system of equations.
All right.
2x squared minus 3y squared equals 30. And then x squared plus y squared equals 25.
Okay. We can treat these exactly as we would treat linear simultaneous equations. In other words, we want to try to eliminate a variable.
Okay.
Now, as with linear equations, there's a number of things we could do. We could multiply the bottom by 3, and then if we add those two equations, we're going to eliminate the y squared variable.
Okay.
Okay, so let's do that. To me, that looks like the easiest thing to do. So that becomes 3x squared, 3y squared, and 75. In other words, I just multiplied the bottom equation by 3. Both sides. Now, you're always allowed to add equations. So when I add these two equations, I get 5x squared. Y term goes away. And that's equal to 105.
Okay.
X squared is equal to 21. What's x equal?
X equals the square root of 21, plus or minus.
Plus or minus square root of 21. And then once you get x squared, then you can go back into the simplest equation, which would be this one.
Mm-hmm.
Plug in that, and y squared is going to equal 4, so y would equal 2, plus or minus 2. You see what I did there? In other words, we're going to plug the x into this equation. So we would have 21 plus y squared equals 25, y squared equals 4, y equals plus or minus 2.
Okay. And then I have one more like this.
Okay.
5x squared plus 3y squared equals 7. And then 3x squared minus 7y squared equals 13.
Okay. In this case, there isn't a single equation that we can multiply by an integer such that everything will, or a variable will disappear. But what else could we do?
I think what I did on this one, when I was going through it, I think I multiplied the bottom equation by -5 and the top one by 3.
That will work just fine. Let's do that. So the bottom one's by -5, and the top one's by 3. So let's rewrite the top one.
Plus 9y squared equals 21.
Let's rewrite the bottom one.
-15 x squared plus 35 y squared equals -65.
Let's add them together.
44y squared equals -44. Y equals plus or minus I.
Okay. Now, to solve for x, let's go back and substitute the y to that equation. Okay.
So would the y just act as a -1 in that case since it's I?
Uh-huh. In other words, if I plug in I in for y, and notice it doesn't matter whether I plug in the plus or the minus, I'm going to square it. So I'm going to have 5x squared plus 3 times -1 equals 7. 5x squared equals 10. X squared equals 2. X equal plus or minus root 2.
All right. And then I need to still go over some
That's fine.
Simplifying type problems.
Yeah, for sure. Whatever you want.
All right, let me send this to you real quick.
Okay. This is different than this one?
Yeah.
Okay.
All right, it's sending.
Okay.
Are you a Broncos fan?
I am. Big one.
I think I'm not sure they're going to win on Sunday.
Going to be a tough game. I think it'll depend on whether Manning is fully healthy or not.
He's not going to be fully healthy. I know that. He's got he has a high ankle sprain and something else is wrong. So.
I haven't gotten it yet.
Yeah, it's
There
just
it is. There it is.
Yeah, there it is.
Here's my options to download it here. It's kind of weird. Hold on. They've done something different here. The first time I've seen this like this. Google has done something different. Okay, which ones?
Let's just go through all the ones that you think are more challenging. Like, for example, 2C and like those kinds of problems.
Okay. What's the cube root of 64? Knowing that it's probably going to be a small integer. In other words, they're not going to ask you that if the answer is 5.216. I presume you can't use a calculator here, so the answer is going to be either 2, 3, 4, or 5. Which one is it?
It's going to be 4.
All right. It's the cube root of -64.
Would that be 4I?
No. It would be -4. Notice that if you take -4, multiply it together 3 times, you get -64.
Okay.
So when you take odd roots of negative numbers, you get negative numbers. In other words, if I look at the square root, or I'm sorry, the cube root of 8, that's equal to 2. Not plus or minus 2, but 2. Only 2 times 2 times 2 equals 8. If I look at the cube root of negative 8, that is minus 2. Only minus 2. So the key is the odd root. If it's odd, you're not going to have plus or minuses. If it's even, you're always going to have plus or minuses.
Okay.
Let's see.
Do 6C.
Okay. What is the square root of 0.04? Here, let's go over a principle first. When I take the square root of a number greater than 1, the answer is always smaller, right? Square root of 9 is 3. When I take the square root of numbers between 0 and 1, the answer is always bigger.
All right.
Okay? It's a key fundamental thing to understand, because otherwise it makes these problems very challenging if you're constantly trying to find a smaller number for an answer. So when we look at the square root of 0.04, the negative sign is not present any kind of a problem. The square root of 0.04 has to be a number bigger than 0.04.
Okay.
Well, what's the square root of 4?
2.
So let's try 0.2. Does that work? What's 0.2 times 0.2?
Point 0.04.
0.04, yeah. In other words, if I multiply 0.2 times 0.2, I get 0.04. So the square root of 0.04 is 0.2. And the fact that they put the negative sign in front of it merely means that it's negative 0.2.
Okay.
In other words, we take the square root of this, and then we bring along the negative sign because it's attached. But it isn't affected by the square root. What's the square root of 0.01?
Uh, 0.1.
Yes. So what is the square root of negative 0.01?
Negative 0.1.
No. Remember, when we take the square root of a negative number, we're going to have I as an answer. Part of it.
Oh, wait. Yeah. 0.1i.
There you go. Because it's the same as this. And this is I, and this is 0.1. So it would be 0.1i. All right. Let's see. What's the cube root of 0.001?
Would that be 0.1 as well?
Uh-huh. What's the cube root of negative 0.001?
0.1i.
No.
Wait.
Remember, you can take cube roots of negative numbers. You just can't take square roots of negative numbers. You can't take even roots of negative numbers. That's what you can't do. But you can take the cube root of a negative number. This would be negative 0.1.
Okay.
Always reverse it. If you multiply that together 3 times by itself, you get negative 0.001.
Okay.
Now, let's see what else we got here. Here, let me expand this a little bit. Gosh, hold on. Sometimes my cursor, I just can't control it. I got to use my mouse. All right, let's see. What's the cube root of 7 cubed?
Would it just be 7?
Uh-huh. Here's how we would show that. Cube root of 7 cubed is equal to 7 cubed to the 1/3 power, right? In other words, this 3 becomes 1/3. And 7 cubed to the 1/3 power, we multiply those together. It's the square root of 7 squared.
Just 7, because that square root is canceling out the square.
What is the 4th root of -7 to the 4th power?
Would that be negative or 7i?
No, that is a good question. Well, let's see. In other words, I'm tempted. I can come up with 2 different answers. I'm not really positive which one is correct. And the reason is that if I write it like this, which is my inclination to do, and multiply the exponents, then I get -7 to the 1. So -7 would be the answer. But if I do it the other way, in other words, if I work from the inside out and take -7 to the 4th power first, that's the same thing as 7 to the 4th power, because it turns that negative sign into a positive. And then if you took the 4th root of 7 to the 4th, you get 7.
So if it's a negative number and it's an odd exponent, it's going to be negative, and if it's an even exponent, it's going to be positive.
Let me put this into Wolfram Alpha and see what they say the answer is, because I'm not sure what the answer is to that. That's such a strange one. Let's see. How do we want to put this in? I want to take the quantity -7, raise it to the 4th power, and then take the 4th root of that whole thing. So raise that to the 0.25 power. Let's see what they give as an answer here. 7. I think this probably depends on the order of operations. Gosh. In other words, do you take the -7 to the 4th power first? Or do you multiply the exponents together first? And it makes a difference. So I'm not certain what the order of operations, proper order of operations is. And unfortunately, Wolfram Alpha doesn't really show it. And that's kind of what we're looking at for sure. We're looking at -7 to the 4th root of that. So according to them, it's 7, which means the order of operations is you do what's inside first, and then you do the root afterwards.
Okay.
What is this one here? The square root of -5 squared.
Which one is this?
B. I can't see the number. Let's see. 8B.
Okay. Would that be
And is that different than this?
Yes, they're different.
Okay. So what's the top one going to be?
5i.
Good. And what would this one be?
I think that one is negative. Is it -5?
No. According to Wolfram Alpha, if we do the inside first, then -5 becomes 25. And then we take the square root of 25, we're going to get 5. For the same reason that fourth root of -7 to the fourth is 7, not -7. But
so are you supposed to do everything that is the most inside first and then work your way out?
yes, that's what I always do. If you have a bunch of nested parentheses, that's exactly what I do. And I do think that's the rule of thumb. I'm not positive with that. That's why I checked Wolfram Alpha, but I'm still not positive because we weren't able to put it like this. We weren't able to use the radical sign. I had to use raising to the 0.25 power. But that should be that same thing there. About the one below it, C. What's the cube root of -5 cubed?
That one would be -5.
Good. It's the square root of 1/64. 9a.
1/8.
What's 9b? What's the square root of 1 over square root of 64?
1/8.
And 9c. What's the cube root of -1/64?
Would that be 1/4 or -1/4?
-1/4. In other words, you can take the cube roots of negative numbers and get negative answers. What is 10b, the square root of 81 over 16?
Just 9/4.
What's 10c? What's the fourth root of 1/16?
Would 10 be just be? It's really the square root of 81 over the square root of 16.
That's correct.
Okay.
In other words, it's the same thing. The square root of a over b is the same as the square root of a over the square root of b.
Okay.
Okay. So c, 10c?
Would that be 1/2?
It would. About 11b.
I'm gonna guess it's either 100 or 1,000.
10 squared. 10 squared. In other words, 10 squared times 10 squared is 10 to the 4th. And that's what
So
they
10
have.
squared is 100. So.
Right. So you're right. The numbers were correct, but there's no need to convert it to those numbers. In other words, what you want to do is cut that decimal point in half. In other words, the easiest way to do these kind of problems is to really say 10 to the 4th to the 1/2 power, multiply the exponents, and you have 10 squared. So let's look at a hard one. The one with the -6, 12, we only have a minute or two left, 12b, or even, let's start with 12a.
That would be So would you think of that as negative 10 times negative 10 times negative 10?
No, remember negative exponents have nothing to do with negative numbers. 10 to the minus 3 is merely reciprocal of 10 to the positive 3. Okay? But don't use that technique. Use the technique we just learned. In other words, make the whole thing to the 1/3 power, multiply the exponents. What do you get?
1/10.
Yes, 10 to the minus 1. So how about 12b? This nasty looking one right there. Oops.
It's 10 to the negative 6. That would be 1/100th.
Well, let's not put it in numbers. Let's leave it in powers of 10.
Okay.
So when you multiply these two exponents, what do we get?
10 to the negative 3rd.
Negative 2.
Or
Multiply
2.
the exponents, it's minus 6/3, which is minus 2, which is what you said, but they're giving us everything in exponential form, so we should give them the answers back in exponential form.
All right.
I would suspect your teacher would prefer this answer to this answer, even though this one might be more precise. All right, let's see if there's any...
But they both do mean the same thing, right?
They do, absolutely, yes. Let's see if there's anything else here that looks like it might give you trouble. 14a?
That would be positive A, or positive.
Well, what are you going to do with that negative sign? Remember, that negative sign is not acted on by that 2. So whatever A is, I'm going to square it. This is going to be positive, and then I'm going to have a negative sign in front of it, so I'm going to be taking the square root of a negative number. So I got to have an I.
So that turned into AI?
Yeah. Now the question is it plus or minus A? And I think it is. Hold on a second. If I said, what is this? In fact, we may have to go back and redo some of these. Is that A? Or is that plus or minus A?
I think that's just A.
Okay. You see why I say that? Doesn't minus A work also? In other words, if I said to you minus A is a solution to this, well, let's plug it in. Minus A squared, and then we take the square root of that. That gives us the same thing. That gives us A. So minus A actually works. It's kind of like when you say the no, it doesn't. In other words, when I put that radical, I'm assuming there's a plus sign in front of it. That's why when I say, what is the square root of 16, the answer is not plus or minus 4, even though minus 4 works. It's presumed when we use the radical sign that there's a plus there, and that because that's why I distinguish between the plus and the minus, is to assume that the radical sign means plus. So this is true. All right. Square root A squared is A, not plus or minus A. All right. Ran over, and I got a 5:30. I got them stacked up tonight. So I will see you on Saturday? Yeah, Saturday at noon.
Okay.
All right, Jackson, good luck on your quiz.
Thank you.
Bye-bye.
Bye.